Hi, welcome to my class in Calculus 2 or Integral Calculus. If subtraction is the inverse operation for addition and division is the inverse operation for multiplication, integration is the inverse operation for differentiation. In integral calculus, we want to find the function whose derivative is given. That is, the derivative of some unknown function is given, and we want to find that unknown function. And the process to find that unknown function is called integration. It is the process of finding an antiderivative. And what is an antiderivative? A function f of x is called the antiderivative of f of x if f prime of x equals f of x. The given here is the function small f of x, and we want to find the function capital F of x, whose derivative denoted by f prime of x is equal to the small f of x. And the process of finding this antiderivative f of x of the function small f of x is called the process of integration. And this is the symbol for integration. It is the stylish form for summation or sum, because in one of the applications of integral calculus, or one of the applications of integration, is finding the area under a given curve whose function is given and bounded by lines or part of the axis of the Cartesian plane. And to find this area under a given curve, we divide the interval that covers the area into sub-intervals. And under each sub-interval, we find the area of the rectangle in each sub-interval. And we approximate the total area under the given curve by getting the sum of the areas of the rectangles in the whole interval that has been divided into sub-intervals. That is why the use of this symbol or notation for integration, the process of integration, it is the stylish form for summation or sum. And we read the integral of f of x dx equals capital F of x plus c. Capital F of x is called the antiderivative, or simply the integral of small f of x. And capital F of x is called the antiderivative of small f of x if the derivative of capital F of x is equal to the small f of x. In this notation, the small f of x is called the integrand, and this symbol is called the integral sign, and dx here indicates that the variable of integration is x. That is, we integrate the small function, the small f of x, the function is small f of x with respect to x, to get this capital, the function capital F of x, known as the antiderivative or integral of f of x. For example, the given function, the function is small f of x equals 2x. The antiderivative of this f of x equals 2x, denoted by capital F of x, is x to the power 2. because if you get the derivative of x squared, this implies f prime of x, the first derivative of f with respect to x is 2x. And 2x is the given function is small f of x. Therefore, the function capital F of x equals x squared is the antiderivative of 2x. Because it satisfies this condition, the derivative f prime of x equals 2x is equal to the function is small f of x, which is 2x. But if we let the antiderivative capital F of x equals x squared plus 1, and if we get the derivative of this function capital F of x, we would also obtain f prime of x equals 2x, which is equal to the given function is small f of x equals 2x. Similarly, if we take the antiderivative f of x as x squared plus a constant 5, and we get the derivative of f of x with respect to x, denoted by f prime of x. The derivative is also 2x. Actually, if you add any constant to x squared and you get the derivative of x squared plus that constant, you will obtain the derivative f prime of x as 2x. That means a given function is small f of x can have many antiderivatives. And in general, we denote the antiderivative of small f of x as f of x plus c, where c is any constant and c is called the constant of integration. Such as in this example, capital F of x equals x squared, and its derivative is equal to the given function is small f of x equals 2x. Thus, the function capital F of x equals x squared is called the antiderivative, or the integral with respect to x of the function is small f of x. But adding any constant such as 1 and 5 to the antiderivative x squared, we would get the same derivative 2x, which is equal to the given function is small f of x equals 2x. Thus, a given function can have more than one antiderivative, and in general, we denote the antiderivative of the function is small f of x by the function capital F of x plus c. Again, we read this as the integral of f of x dx equals f of x plus c, where small f of x is called the integrand, and this is the integral sign, and dx indicates that we are integrating with respect to the variable x, or dx indicates that the variable of integration is x. Capital F of x is called the antiderivative of the function is small f of x, and capital C here is called the constant of integration. Whenever you find the antiderivative of the given function is small f of x, we always add a constant of integration to the antiderivative capital F of x, where C here is any constant. And to find the antiderivatives of functions, there are integration rules and integration techniques. And today we will start with what is known as the power rule. The first rule in finding the antiderivative of a function, given function, is what is known as the power rule. And the power rule is given by this. The integral of x to the n with respect to x is equal to x to the power n plus 1 over n plus 1 plus c. In our definition of antiderivative, our function is small f of x is now x to the power n. The variable of integration is indicated by dx is the variable x. And the antiderivative of x to the n is given by x to the n plus 1 divided by n plus 1. This is the function capital F of x in our definition of antiderivative. But the complete set of antiderivatives for the small function, the function is small f of x equals x to the n, is x to the n plus 1 divided by n plus 1 plus c. Notice that in the antiderivative, 1 is added to the exponent of x. The integrand here is x to the n. In the antiderivative, 1 is added to the exponent of x in the integrand. And x to the n plus 1 is divided by n plus 1. The original exponent of x in the integrand plus 1. N plus 1 is used as divisor plus the constant of integration c. Before we take an application or examples for applying the power rule, I would like to differentiate between two types of integrals. The two types of integrals are indefinite integral and definite integral. And it's quite easy to recognize the difference between indefinite or definite and definite integral, or it's easy for you to determine whether the given is indefinite or definite integral. Indefinite integral, we have limits in the integral sign. A and B are called the limits of integration. And in particular, small a is called the lower limit of integration, while small b is called the upper limit of integration. After we find indefinite integral or definite integration, after we find the antiderivative of the function is small f of x, we evaluate that antiderivative from a to b. That is, if the function capital F of x is the antiderivative of the function is small f of x, we evaluate this from a to b. And to evaluate this function capital F of x from a to b, we start from b, replace x in the function capital F of x with b. We get f of b minus, evaluate the antiderivative capital F of x by substituting a for x, and we get f of b. F of a. Again, in definite integration, there are limits in the integral sign. And the antiderivative of the function is small f of x is evaluated from a to b, evaluated at the limits of integration. And in evaluating the antiderivative at the limits of integration, we start from x equals b, replace x with b in the antiderivative f of x. You get f of b minus substitute a for x in the antiderivative, you get f of a. In definite integration, the answer is a single number or a single numerical quantity. In indefinite integral, there are no limits in the integral sign. And the answer here is not a single number but a set of antiderivatives. If the antiderivative of the function is small f of x is capital, the function capital F of x, we add a constant of integration, and this represents a set or family of antiderivatives for the function is small f of x. Again, in indefinite integral or in indefinite integration, there are no lower and upper limits in the integral sign. And after the process of integration, the answer is a family of antiderivatives denoted by f of x plus c. In definite integral or definite integration, there are limits in the integral sign. The upper number is the upper limit of the integration. The lower number is the lower limit of the integration. And after you integrate, after you find the antiderivative of the function small f of x, there is no need to add a constant of integration. The antiderivative capital F of x is evaluated at the limits of integration from a to b. And to evaluate the antiderivative capital F of x at the limits of integration, we start with the upper limit of integration. Substitute the upper limit of integration for x in the antiderivative f of x to get f of b, minus substitute the lower limit of integration at the antiderivative capital F of x to get f of a. These are the two types of integrals, indefinite integral and definite integral. And now we take an example for using the power rule. Given by this rule, the integral of x to the n with respect to x equals x to the n plus 1. 1 is always added to the exponent of the integral x to the n, and the sum is used as divisor of x to the n plus 1. And a constant of integration is always added to this antiderivative. In applying the power rule, the integrand must consist of a single x raised to an exponent. If the integrand contains a product of x to different exponents, then you have to express this product as an integrand with only one x raised to an exponent. We take one example. We find the integral of dx over x to the power 3. Also, in using the power rule, the integrand x to the n must be in the numerator. But in this example 1, our integrand is 1 over x to the power 3. And you have to bring this in the numerator. The integrand is multiplied by differential of x or dx. The given integral must be expressed in this form. Integral of the integrand multiplied by dx. But here in the given integral, we have differential of x or dx divided by the x to the 3. So what we do first, we bring x to the power 3 to the numerator, and by property of exponent, if you bring a an exponent from the denominator to the numerator, or from the numerator to the denominator, you always take the opposite sign of the exponent. And this is positive 3. If we bring it up in the numerator, we get x to the minus 3 dx. Now this is now in the form x to the n dx, where the exponent n is negative 3. In the power rule, n is negative 3. And by the power rule, the integral of x to the n with respect to x is equal to x to the n plus 1. Where in our example, n is negative 3. Negative 3 plus 1. We have x to the negative 3 plus 1 over n plus 1. Our n is negative 3. Negative 3 plus 1 plus a constant of integration. And we simplify. Negative 3 plus 1 is negative 2. We have x to the negative 2. Divide by negative 3 plus 1 is negative 2. Plus c. In the final answer, we want to remove all the negative exponents in the final answer. So what we do is to bring x to the negative 2 to the denominator. And what is left in the numerator is 1. Hence, we can write the final answer as negative 1/2. Or negative 1 over 2 times x to the power 2 plus c. We bring x to the negative 2 in the denominator, and we take the opposite sign of negative 2. That's why we have x squared. And we have 2 in the denominator. That's why we have 2x squared. And we write negative here, the sign of 2, plus the constant of integration. If you want to check, you get the derivative of negative 1/2, negative 1 over 2x squared, you get its derivative. And you should get 1 over x cubed. And the derivative of c is a constant, its derivative is 0. For our second example, consider the following problem. Integrate t squared times the root of t with respect to t. Again, this is an example of indefinite integral. Or the process involved here is indefinite integration because there are no limits in the integral sign. And to apply the power rule, in the power rule, the integrand consists of a single variable raised to an exponent. But in example 2, we have a product of t squared and the root of t. And we have to express this integrand as an integrand with only one t raised to some exponent. So we will do that first. We write the integral of t squared multiplied by property of radical. The root of t is written as t raised to 1/2. Or in general, the property of radical says the nth root of x to the m is equal to x to the m over n. To the square root of t, we apply this property of radical that says the nth root of x to the m equals x to the m over n. The index n here becomes the denominator of the exponent of x. And here, for the square root of 2, the index is 2. If the index is 2, 2 is no longer written. So if you see a radical sign with no index, it means that the index is 2. And this indicates that you want the root of 2. The root of t. So the square root of t is equal to t raised to 1/2. And we integrate with respect to t. And here we still have a product of 2 expression with t. And we have to express them with a single t. Hence we apply the property of exponent. We are multiplying exponents with common base of t, copy the common base t, and add the exponents 2 plus 1/2. And we integrate with respect to t, dt, and we get integral of t. 2 plus 1/2 is 5/2. Integrate with respect to t. How did we get 5/2? You multiply 2 here by 2/2, so that the common denominator is 2, and 2 by 2 is 4 plus 1 is 5. Now this is now in this form where the integrand consists of a single variable raised to an exponent n. And in this example, our exponent n is 5/2. And by the power rule, the integral of x to the n with respect to x is x to the n plus 1. But here with respect to t, the integral of t raised to 5/2 is t raised to n 5/2 plus 1. It's always plus 1 in the exponent of the variable. Divide by this sum 5/2 plus 1 plus the constant of integration c. We always add c. This is the antiderivative, and to get the set of antiderivatives, we always add a constant of integration c. And we simplify. Five over 2 plus 1 is 7/2. We get t to the power 7/2 divide by 5/2 plus 1 is 7/2 plus c. And we simplify this complex fraction. The numerator is t to the power 7/2 multiplied by the reciprocal of the denominator. Reciprocal of 7/2 is 2/7 plus c. In the final answer, we simplify the antiderivative, get the root of the powers of t that has a root. So we write 2/7, and t raised to 7/2 is the same as the root of t raised to 7 plus c. And we write 2/7. Now the t raised to 7 can be written as t to the power 6 multiplied by t plus c. And we rewrite t raised to 7 as t to the power 6 times t, so that we can get the root of t raised to 6. And the root of t raised to 6 is t to the power 3. So this simplifies to 2 over 7 multiplied by t cubed multiplied by the root of t plus a constant of integration c. And this is the antiderivative or the integral of t squared times square root of t. With plus c, you get the family of antiderivatives or the set of antiderivatives for t squared times the root of t. Because if you substitute any constant to capital C, to the constant of integration c, 2 over 7 times t cubed times the root of t plus any constant will give you, and if you get that derivative, will give you this integrand t squared times the root of t. For our third example, consider the following problem. Integrate y squared over cube root of y squared with respect to y. This is the integrand y squared over the cube root of y squared. As indicated by dy, the variable of integration is y. And this is an example of indefinite integration. And we have to express the integrand with a single y raised to some exponent. Thus, we rewrite this as the integral of y squared. Again, apply the property of radical to write this cube root of y squared as y raised to a rational exponent. By this property, the nth root of x to the m equals x raised to m over n. Here, the index n is 3, and the exponent m of x is 2. So the cube root of y squared by this property of radical is equal to y to the power 2 over 3. And we integrate with respect to y. And you can see the integrand is not yet an expression with a single y raised to an exponent. Thus, we simplify further by taking this denominator y to the power 2/3 to the numerator. And we write the integral of y squared multiplied by, whenever you take an exponent to the numerator, from the numerator to the denominator, or you take an exponent with from the denominator to the numerator, we take the opposite side. And we want to bring this y raised to 2/3 to the numerator. So we multiply y squared by y to the negative 2/3. And we integrate with respect to y. And now apply the property of exponent. We are multiplying with the common base of y, copy y. And we add the exponent, 2 plus negative 2/3 or 2 minus 2/3. Integrate with respect to y. And we simplify the exponent. 2 minus 2/3 is multiply 2 by 3 over 3. So that the common denominator is 3. And in the numerator, you have 2 by 3 is 6, minus 2 is 4. 4/3, we integrate with respect to y. In this integrand now, the exponent n in the power rule is 4 over 3. N is 4 over 3. And we now integrate y raised to 4/3 with respect to y, and by power rule it's equal to the variable of integration. Here the variable of integration is y raised to n 4 over 3 always plus 1. 4 over 3 plus 1. And whatever you get, whatever sum you get in the exponent, you use that as the divisor of the antiderivative 4/3 plus 1. And don't forget the constant of integration c. We simplify the exponent 4/3 plus 1. Again, we multiply 1 by 3 over 3 so that the common denominator is 3. In the numerator, we have 4 plus 1 by 3 is 7. And this sum is the divisor, 7 over 3 plus c. Again, we simplify. We always want to write the final answer in the most simplified form. And this is equal to the numerator. The numerator y raised to 7 over 3 is the same as the cube root. The cube root of y raised to 7 by this property of radical. Multiply by the reciprocal of 7 over 3. The reciprocal is 3 over 7. Plus the constant of integration. We have 3 over 7. Again, we rewrite y raised to 7 as y raised to 6 multiplied by y raised to 1. We have the cube root of y raised to 6 multiplied by y raised to 1 plus c. Six plus 1 here is 7. And we write 7 as 6 plus 1 because 6 is divisible by 3. So we can get the cube root of y raised to 6, which is y squared, multiplied by the cube root of y. So this is equal to 3 over 7 times the cube root of y raised to 6 is y squared. Multiply, we can rewrite this. The cube root of y raised to 6 times y as the cube root of y raised to 6, which is y squared times the cube root of y times the cube root of y plus c. This is the set of antiderivatives of this integrand. And you can check that if you get the derivative of this, 3 over 7 times y squared times cube root of y plus any constant, the derivative of this will give you this, should give you this integrand. For our last example, consider the integral of dx. To find the integral of dx, we also apply the power rule. The integrand here is not dx. The integrand is 1. Hence, we can rewrite the integral of dx as 1 multiplied by dx. And to apply the power rule to the integral of 1 times dx, we write 1 as x to the power 0. We write this as the integral of x to the power 0 dx. By property of exponent, x to the power 0 is 1, provided the base x is not 0. So here we assume that the base x here is not 0, so that we can rewrite 1 as x to the power 0. And in the power rule, the exponent n is 0. And according to the power rule, the integral of x to the 0 with respect to x is equal to x to the power 0 plus 1 divide by 0 plus 1 plus the constant of integration c. But x to the 0 plus 1, 0 plus 1 is 1. And in the divisor, 0 plus 1 is 1. In the numerator simplifies to 1. Sorry, to x raised to 1 or simply x. And divide by 1, we get x plus c. Therefore, the integral of dx is simply x plus c. If you are integrating, if the given integral is the integral of the differential of a variable, then in general, if the given integral is the integral of the differential of a variable such as dx, then the integral of the differential of that variable is the variable of integration plus a constant c. For your exercises, please try the following problems. Integrate. To integrate means is to find the antiderivative or the family of antiderivatives whose derivative is equal to the integrand in the given indefinite integral. These exercises involve indefinite integration because there are no limits in the integral sign. And in these exercises, you apply the power rule. In number 1, we have the integral of x to the 6, and the variable of integration is x. In number 2, we have the integral of the square root of t over t raised to the power 3. You integrate with respect to t. You have to rewrite this first as an integrand with a single variable t raised to some exponent by applying property of radical and property of exponent. Similarly, in number 3, you have to simplify the given integrand to express it as an integrand with a single variable y raised to some exponent by applying the property of radical and property of exponent. The variable of integration in number 3 is y. In number 3, you have the integral of the cube root of y squared over the square root of y. And you integrate with respect to y. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalison. Thank you.